Hello, you're welcome back to Quiver Analytics, and this is Python for Data Science, Exploratory Data Analysis, and Descriptive Statistics. All right, so we'll be using these scripts, and this is the data set that will be used: student habits performance. All right, so EDA helps you to understand the structure, relationship patterns, and anomalies in your data before applying any machine learning models or any model at all. So in essence, before you start your addressing the objectives of your data science project, these are some of the steps you should look into. Now, the first thing we do as usual is to bring in the libraries. Have Pandas and NumPy, Matplotlib, Seaborn. Then we load the data set. So because the data set is inside the working directory, so we just load it using the pd.read underscore CSV, then the name of the data file. So what I meant by it being in the working directory, this is the folder I'm using, and here you can see the data, then you can see the scripts. So your scripts and your data, if they are in the same folder, we call it working directory. If they are in the same folder, then you can run this. You can call your data without having to specify the whole path. All right, so you can run this, and we have the data set in df. Now to display the top data, we can, by default it gives us the first 5, that's df.head, the top 5 rows. So if we do that, we have 0 1 2 3 4, that's 5 rows. Remember, Python starts counting, it starts indexing from 0. So we have 0 1 2 3 4, that's 5 rows. At the same time, if you want the last rows, okay, before I go to the last rows, so if you want more than 5 or less than 5, you can specify your number here. So assuming I want 7, I can run that, then it gives me 7, the top 7 rows. All right, so but by default it gives me the top 5 rows. All right, so again, looking for to display the last rows, by default it will give you the last 5 rows. That's using the df, whatever the name of your data frame is, dot tail, to give you the last 5 rows. So let's see. So you can see from 999, 995. All right, so in essence it means we have 1000 rows because the indexing, the numbering starts from 0. So now to look at the shape of the data, shape means the dimension of the data, as it's usually given in rows by column. So it implies that we have 1,000 rows and 16 columns. All right, so it's important to note that because we'll be working with that soon. 1,000 rows and 16 columns. So to display the details, we've been looking at the top 5, the last 5, the dimension. So to look at the individual variables, just write name of your data set dot info and leave the brackets blank. So you can see we have object, integer, object, floats. These are the 3 types of data type that we have in this info, displaying this output rather. Another interesting thing is you can see here we have non-null count. That's how many entries are in student ID that are not null. We have 1000 here. Age, we have 1000. Gender, 1000. Study hours per day, we have 999. Social media hours, 1000. So study hours per day, that means 1 is missing. part-time job, one is missing, and so on. And parental educational level, 91 seem missing here. So there are 91 missing uh, entries in this column. Alright, so we will deal with how to deal with we'll treat how to deal with missing values. Now, for descriptive statistics, it helps us to dive more into the data, to explore more the data. So a general one is to do describe, the name of data set dot describe, and if you run it, so we have what describe does is it gives us the uh, integer, the numeric variables, the summary of numeric variables. You can see the counts, the mean, we can't have mean for age, so it leaves out um, mean for, I mean, it leaves out categorical variables altogether. So we have the mean, standard deviation, minimum, 25%, we have maximum. All right. So now to look at descriptives, categorical data are also part of the data. So we can't say because describe will not display it and will not, that means we will not explore it. No, we still have to explore it. So for categorical data, usually we have factors. For example, gender. The factors under gender are male, female, and others. All right. So we can check the frequency for for the gender factors using dot value counts. So we select the column gender using this selection method using the square brackets, then value counts. If you run this, you can see we have female 481, male 477, and other 42. We can as well display the percentages by adding normalize equals true times 1000. Without this times 1000, it will just give us the ratio. All right, so times 1000 would give us the percentage. We have female 48.1%, male 47.7%, and other 4.2. So why they rhyme is because it is 1000. They are all, it is 1000. So that's why it's same, like it just did decimal place back. All right. So to display both frequency and percentage, we join the code for frequency and the code for percentage. So we run this, and you can see we have frequency and percentage. And right now, visualizing frequency and percentage. This, we've treated this before in the previous video. So, however, let's go through it. So here, I'm I'm assigning the value count for gender into gender counts, and assigning the normalize, that's the percentage for gender, into the percentage. Now we want to plot both charts. We want to plot bar chart for gender counts, then bar chart for percentages. So the subplots, we have 1 and 2, figure size 10 and 10 by 4. So the bar charts here, then the second bar charts here as well. So if we do this, so depending on what you want to present, you might want to present your charts in percentage, you use this method. You might want to present your charts in frequency, the actual frequencies, you use this method as well. All right, so if you also want to explore categorical and categorical data or variable, here we are exploring gender by diet quality. The diet quality is fair, good, and poor. All right, so if we run this, it gives us okay, this is a group bar chart. It puts this, you can see the stacked equals false, makes it to be beside each other. For proper explanation, you can check the previous video. All right, so changing it to stacked equals true makes it a components bar chart. right? I prefer the former. All right, so for a single numerical value, uh, so we've learned about um, doing the frequencies for a single categorical value. This time around, if you're interested in a single numerical value, we call it out, we call that column out and use dot describe, which is what we use for the whole data sets in the first place. So we have this. Then to visualize the distribution, again, want to visualize, revise how to visualize distribution of a single numerical variable, which we can use Boxplots or we can use histogram with the density plots as well. So we'll do that again into subplots, and it's the same variable showing us two different things. This is the 50th percentile, the middle line, and then the outliers, and then we have the distribution, which is normally distributed, and then the density plots plotted across the histogram. All right. Now, how do we undo? We've seen that there are missing values, but specifically we need to run the is null and then sum it, and it will return number of missing for each column. So for this column, study hours per day, one is missing, which we've seen before, and the part-time, one is missing, attendance percentage, one is missing, while parental education 91 is missing. All right, so now this can also be visualized, and let's see that. So you can see where the missing values appear. So the missing values for the first three, I guess, are in the zero index, that's in the 0th row, while the rest are spread across this parental education column, the other 91 or thereabouts. All right, so now what do we do to missing values? We can't just leave them. So most of the time, what we do is just to remove or we replace it by mean. And here we have the df.drop na, that's to remove. If you want to replace the main value, example for age, this is what to do. All right, so you are going to drop na, and then we check if missing values exist after. All right, so you can see no more missing values, everything is now 0, 0, 0. Then if you check the shape now, we should have lesser rows. We used to have 1000 rows, now we have 907 rows. We still have 16 columns as well. So assuming we have duplicates, we would have run this part of the code, but we do not have duplicates. However, let's run it. So you can see there are no duplicates. If we had, it would have removed duplicates here and would have had less than 907 rows. All right, now here on understanding data types and transforming them. So what this entails is that, okay, so again, let's see the data types that we have. We have object, we have integer, we have float 64. So the floats data type usually are numbers that have decimal points there, while integer are numbers that are whole numbers. So whole numbers, no decimal points. So we can go from float to integer or integer to floats. There are other types of data, for example categorical, which is what we'll be working on in a few seconds. All right, so we can convert objects to categorical. Now categorical is a good form. I would suggest that when you get your data for your project, your categorical data like gender should be turned into, it's a categorical data by default. I call it categorical data. Your text data like gender, which has factors, should be transformed to categorical form. So how do we transform? The key word for transforming is the as type. like make this gender as type category. So once we do that, I will pass it into gender in the data frame. If we check the data type for gender, you can see categorical data type categories. So now it understands that female, male order are actually categories in this data set or in this variable. All right, so you can ask why what's the essence for analysis like chi-square or Spearman correlation. Well, Spearman, you can see Spearman correlation. For chi-square, most times chi-square is the test of contingency between two categorical variable. All right, so um, it's good to make Python know that this is a categorical variable so that it can understand the categories. All right. Now, you know, in a case where we have a lot of categorical variables in the or a lot of object variables in the data sets, um, you can do it in bulk like this, assign everything to a list, then you apply the as type for the list. All right, so if I run that, all these things that were objects earlier has turned to categories. You can see we had gender was objects, and part-time job was object, diet quality was object. You can see part-time job category, diet quality category, and the rest became category. Now again, we can convert numbers. Like I said, we can convert floats columns to integer. Doing that would run this code. I intentionally did not run it. I wrote it in a markdown cell so that I won't be able to run it here because I'm not interested in changing my integers. So I'm just going to leave them that way. Right, but you can try them out. Try different ones out. Now let's talk about outliers. Now, outliers are data points that differ significantly from other observations and can distort analysis results. It can distort the analysis results greatly. All right. So we are going to be plotting the box plots to identify uh, outlier, if there exists outlier or not, and then we use the IQR method to remove the outlier if they exist. So we use it to locate them, and then we also remove it if they exist. All right, so the box plots, here we have the box plots, and then to get the outliers away, we have to get the quartile 1, quartile 3, the interquartile range, and then apply this formula to remove it. So let's run this and see what we have. So this is the box plot for exam score, and there are two people who scored um, extremely low. All right, so because they scored extremely low, we really can't include them among, they differ significantly from others, and we can't use them to judge the over 900 students that we have there. So they've been removed, and so we check the box plot again to see if truly they have been removed. Yeah, they have been removed, and then we check because when they were removed, they were inserted into DF, no outliers. So that's the new data, and then we can check this out. The shape now is 905. That means we removed two data points, two rows. So now we have 905 rows, making a total of 94 cells, rows that has been removed. Finally, for feature engineering, we have so for feature engineering, this what we'll be examining here is how to convert numerical variables to categorical, and how to group numerical variables to make them into factors or categorical, and then how to map categorical. For example, gender is in text. While some models will not understand what we have in text, we have to transform them to numbers. That process is what is called mapping. All right, so the first instance that was said is converting numerical values into groups. So create age group. So once creates, we've seen age to be numerical. So here we want to classify those numbers into groups. We want for them to classify those numbers into groups or into factors. So we use pd.cut df age bins 0 to 0. We have 0 to 17, 18 to 34. That's how it's going to classify them, and their labels, corresponding labels will be respective labels will be teen, that's from 0 to 18 probably. Then we have young adults, adults, and senior. All right. So yeah, so let's see that and display the variables. uh, I mean their frequencies. This is their frequencies, so that means in these data sets, because the student data set, so it's expected that we do not have adults, neither do we have seniors. All right. So if you check df.shape, we still have 107 dots and 107 by 17. So that means this has added another column to the data set, which is age group. What we had before was age, which contains the actual age. This time around, we now have age group added to it, which is classification of the ages. Now, for mapping, so we are going to create a dictionary to define our mapping. Males should be 1, female should be 2, other should be 3. So male serve as the key, while 1 is the value. All right. So we set it as intersex mapping, while option 1, create a new column with numeric codes, and so we do this to ensure that this works. And let's see what we have. Then if we do the counts, and then you can see 1 is male because the frequency is 440 and 440 here as well. Then 2 is female, 431, 431, and so on. So we have another variable added to this. So again, let me go and run df.shape. You would see we have 18 columns now. So we have 18 columns. All right. So I know I have not removed the outliers here. Yeah. So that's why I still have 907. The where I remove the outlier, it is the df no outlier. All right. So however, we are good for these data sets. As far as this data set is concerned, it is good for analysis, and then it can be downloaded as CSV, at least for keeps. Then later you can transfer the data anywhere or load it again. Okay, you don't even have to load it into here, it's already there. All right, so thank you, and don't forget to like, don't forget to follow, don't forget to share and subscribe to our YouTube channels and all of our social media outlets. That's Quiver Analytics. All right, thank you, and see you in the next class.